Welcome back to Conservation Connection, the show where we do exactly what it sounds like, connect you with people working in conservation. I'm Sarah Catherine.
I'm Chance.
And this is the show. So we're kind of back to our regularly scheduled programming this week after we were at EarthX. Last week, it was an amazing experience. Chance, my question for you is, what was your favorite thing that you ate at EarthX while we were in Dallas this week?
That's an easy answer. The answer is breakfast tacos.
Oh, yeah.
As a Texas native, you can't get good breakfast tacos like Tex-Mex breakfast tacos outside of Texas. I'm sure that is an unfair blanket statement, and there are plenty of excellent breakfast tacos. I just haven't been able to find them. So I literally had breakfast tacos for dinner. I DoorDashed breakfast tacos to our hotel room. There were amazing food at like the banquets and the breakfasts and all that sort of stuff provided by EarthX, but it's going to easily be breakfast tacos.
Yeah, I'm not surprised.
Which like kind of goes back into this I love getting back to Texas. As my home state, it's always good to spend time there and to be in a different ecosystem. And then we come back here to the East Coast. And I was telling you that one of the biggest differences I see from Central Texas to the East Coast where we live is just how tall the trees get. Unless you're literally by a river or a creek in Texas, your trees are capping out at like 30 feet tall, at least once you get out of Eastern Texas. Whereas here in Georgia, there's pine trees that are 60, 70 feet tall everywhere. So it was just good to be home for a little bit.
Yeah, I mean, we were walking around and you were like, the trees are so short. You were like, you don't notice it? And I was like, I don't know. I guess I don't pay attention. I'm used to tall trees. And I mean, once you pointed it out, I noticed that the trees in Texas were shorter, but
I feel like that happens a lot in nature, though, that like people don't notice stuff until it's pointed out to them and then you see it everywhere. Like that's happening right now with the cicadas.
Yeah.
People are like, what is this weird sound that's going on?
Oh, yeah. Everybody on like our Ring notifications are like, what is this loud noise? Why is there this loud noise? And they're talking about the cicadas and it's just crazy. I mean, this happened last year, too. We had cicadas last year.
Yeah, I think this is a special year for cicadas a little bit because there's this like discussion of the 13-year cicada and the 17-year cicada are all emerging at the same time. But there's also a lot of, I don't want to call it fear mongering because nobody's like, you're going to get eaten by cicadas. But there's a lot of like misinformation about what that actually means. But definitely there are a lot of cicadas around this year.
Yeah, for sure.
Anyway, getting into kind of our topic du jour. This week we're talking all about oysters.
Woohoo! We love oysters. Oysters are really cool, and some of us think they're tasty.
One of my favorite memories of oysters that I know that you remember as well.
Yeah.
The night that we got engaged, we were living in the Florida Keys and I proposed just before sunset. We went and watched the sunset and walked around kind of by the waterfront. And then we went to a restaurant and ordered a dozen oysters in celebration. And as I was about to eat one, did I say it or did you say it?
No, I was like, how crazy would it be if like there was a pearl, like if we found a pearl in one of these oysters, and our audience probably knows where this story is going.
Because 10 seconds later, I ate the oyster and spit out a pearl, which we then got mounted into a necklace for you as sort of this beautiful reminder of getting engaged in the Keys.
I was like, were you like hiding this in your cheek the whole time? Like, what the heck?
Which would have been a pro move, but no, I promise you that is a wild pearl from an oyster. I wish we knew where those oysters had come from.
Oh, yeah, that's interesting. I don't know.
There's definitely not any way to like
call them and be like, hey, in 20 whatever.
Yeah, definitely not, but it would be cool. But anyway, all of that is to say that oysters are really important in ecosystems. They're this very interesting intersection between the environment and human needs, human desires, how we eat them and interact with them as a food source.
Yeah, it's really interesting because we did our kind of mini episode about EarthX last week, but the week before we were talking about the North Atlantic right whales. So we're going from this episode about these larger than life animals to like these little itty bitty oysters that
little
like
snot
just,
rocks.
Gross. That just kind of hang out and are very different from the whales we talked about in our last episode.
Yeah, this was a really sciencey episode. So just to kind of lay a solid foundation for some of the terminology that we use, one word that we talk about a lot is recruitment, which is the sciencey way of saying new juveniles appearing in the population. So in terms of oyster, it's literally like when the free-floating spawn lands on a spot and starts building a new oyster shell. That's recruitment. And then the other thing that is super cool about oysters and oyster aquaculture in particular is the genetics behind some of the work that they're doing.
I blacked out a little bit during this part of our conversation and the actual recording of this conversation because I was like, wow, this is... And Chance says it right before he starts talking. He was like, we're going to get really into the science for a second here. And I was like, oh gosh. But listening back to it, I'm like, okay, that makes sense.
Yeah. And really, so what we're talking about is the difference between diploid, triploid, and tetraploid organisms. In simple terms, most cells have 2 pairs of each chromosome. So in a human cell, a normal human cell, we have 23 pairs of chromosomes for a total of 46 chromosomes. That's diploid, di meaning 2. So when we talk about women having 2 X chromosomes, they have 2 copies of the X chromosome. Triploid organisms, or triploid cells, would have 3 copies of each chromosome. If there were 23 types of chromosomes, that would be a total of 69 individual chromosomes. They're triplicate, right? Triploid. In tetraploid organisms, there's 4 copies of each chromosome. So if we have 23 types of chromosomes, that times 4 would get you to 92 total chromosomes in each cell.
And why does that matter?
That's a great question. So it matters because triploid organisms have a really hard time reproducing. When they go to make sperm or egg cells, you divide your nucleus, which has all your chromosomes, in half effectively. And if you've only got 2 copies of each chromosome, it's pretty easy to do that. One goes to this cell, one goes to that cell. If you're a triploid organism and you have 3 copies, as you're dividing that in half, it's really difficult to get the right number of chromosomes into each cell that's being divided. And if things don't line up properly, you're not going to end up with a viable baby, basically.
Right.
But the other side of that is that because they don't try to reproduce, or they're bad at reproducing, they put more energy into building their body and having good, meaty, juicy oysters to sell on the market.
Yeah, I think that makes sense. And it is like a brief part of this episode, but I think it gives good context of like in hatcheries, like the one that Justin works at the UGA Marine Extension, they are getting these triploid oysters.
Babies. Tiny.
Little babies. They're getting these larvae that they can grow for a little bit. So they're big enough to be planted essentially out in the water on these oyster reefs by these oyster farmers. So they can go out, find their new homes. They grow really fast. They don't reproduce, so they don't get like skinny and watery during certain seasons, and they can be harvested more quickly, which means that we have more oysters to be put on the market. So that's kind of the benefit of these and having them as opposed to just like your normal reproductive regular old oysters.
And we talk a lot about restoration of oyster reefs, which is also really important because about 85% of the world's oyster reefs have been destroyed over the last 120 years. Like one of the really interesting things for me that comes out of this episode is that we talk about Georgia's oysters as a really healthy population. That's on the east coast of Georgia, right? Compare that to the Gulf Coast of Florida, where they're having a much harder time.
Yeah, so, growing up, I went down to the Gulf of Mexico. That's where we took our vacations. We would go over to Apalachicola, and they were just known for their oysters. So, you would see all these ships coming in and out and the oyster harvesting going on there. They're like the oyster capital, right?
They're called Oyster City.
Yeah.
One of my all-time favorite breweries is Oyster City Brewing Company in Apalachicola. But at one point, they produced, what was it?
So at one point, Apalachicola Bay and the Gulf of Mexico provided 90% of Florida's oysters.
That's a lot.
Yeah.
So they were harvesting a ton of oysters from the wild population. That's this really productive, or was this really productive oyster harvesting area. But they're at the outflow of the Chattahoochee River, which comes basically from Atlanta and goes through a lot of agricultural stuff, as well as the Flint River, which is right next to a lot of agricultural production. And so the water quality coming out of the river into the bay was really getting degraded as we were growing more stuff, and there was more siltation and nutrients in the water causing bacterial and algal blooms, etc. And so between all of these water quality issues and the excessive harvesting that was happening, they actually have had to shut down wild oyster harvesting in Apalachicola. In 2020, they said, in order to allow our oysters to recover, we're not going to commercially harvest wild oysters from Apalachicola Bay for 5 full years. I mean, imagine Vidalia, Georgia, where Vidalia onions are grown, having to say, oh, our soil is so bad that we can't grow Vidalia onions for 5 years. It's like what this place is known for.
And they are seeing success in, so that started in, I think, December of 2020. So now we're in almost May of 2024. And in that time, they have seen success with rebuilding these oyster reefs and helping these populations grow. And then, of course, you also have oyster aquaculture and farming. And that's been really successful in this area in the meantime.
Yeah, actually, I was reading something that was like there's over 100 oyster farmers in Apalachicola Bay because although you can't harvest from the wild reef anymore, you can grow oysters in oyster farming gear like floating cages and stuff like that.
And we talk about that a lot in this episode. The ways that oysters can be farmed in the ocean now to avoid taking oysters from these natural reefs that we're trying to kind of revitalize. So this episode specifically focuses more on Georgia oysters, but I think it's important to kind of contextualize and know that there's oysters being grown all over. Some populations are doing better than others. Some populations face different stressors. Oysters just have a lot going on at the moment. And I'm glad we got to tell this story in this season because I think it's, they do play a vital role in the ecosystem. And we'll probably do another episode sometime in the future, I'd imagine, on like carbon sequestration and oysters and like all this other stuff that they do.
Yeah. Oysters are super cool. So I hope you guys enjoy this interview that we got to do with Justin Manley. We are really excited to be sitting down here with Justin Manley. He is the hatcheries manager here at the Shellfish Research Laboratory at the UGA Marine Extension and Georgia Sea Grant here on Skidaway Island.
Welcome to the show.
Thank you. I'll try not to disappoint.
I don't think you will.
We have already been chatting for a couple of minutes just in the pre-interview, and I'm very excited for this conversation. So basically what we're going to be talking about today is oysters in Georgia and the role of oysters as environmental engineers and, kind of this really important species in a very productive estuary, as well as how we can support native populations of oysters through aquaculture and actually growing oysters, starting them in a hatchery.
Yeah, we wanted to have an episode on this season about oysters because oysters play a really cool and important role in the ecosystem, but also lots of people think they're tasty. So thank you very much for joining us.
My pleasure.
So let's dive in here with just a little background question for you of why are you so excited about oysters in Georgia? How did you get into what you're doing today?
Oh, that's a long, winding road, but I think I'll try to keep it as short and straight as I possibly can. I think that there's epic potential for farming oysters here in Georgia. We have one of the healthiest ecosystems on the eastern seaboard of the United States. We have these large tides, these healthy oyster populations. Oyster recruitment is exceptionally high here because of the health of the population, and I think that due to the remote nature of where you can farm oysters here, we have a lot of areas that could be used effectively to increase production within the state. Being somebody that's, I think, business-oriented, I see a lot of opportunity here for investment. Before peanuts were a big thing in Georgia, I half wonder if people used to think that Jimmy Carter was crazy. But he wasn't, obviously, and I think that the future for oyster farming here is going to look good, especially with the new regulations that have passed that allow water column farming. It increases opportunities in areas that can be used. We used to be intertidal. So really, it's just a whole bunch of things that make this a advantageous environment for the farming of oysters and the expansion of aquaculture along our coast.
It's kind of this perfect storm, like you're saying, of we have really great estuaries for it. We have a very healthy native oyster population that's producing a lot of spat, right? Is that the right term? A lot of spawn?
So that, I think it's becoming a technical term, and what that basically means is a post-settlement juvenile oyster. So, a common term we also use is young of the year. You'll see in some of the older literature, it'll say YOY oysters. Well, what that means is the first settlement of the year. So oysters, to give everybody listening a little bit of a background, oysters are broadcast spawners. And in nature, what happens is they release their eggs and their sperm in the water column due to certain stimuli, one of them being a rapid change in water temperature. Fertilization occurs there, and they spend between 14 and 21 days in the water column, developing, eating phytoplankton, growing. And when they're ready to settle, which you can tell by looking at a larval oyster, they'll have a little eye spot and what looks like a little foot sticking out. It's called a pedivelager. They'll taste around ideal settlement habitats like oyster reefs, mom and dad, and settle. And once they settle, they form these nice little discs, and those little discs are oysters. They've attached, they're starting the whole entire cementation and shell production process, and they're now part of the natural reef. What was the original question again?
Well, we were just talking about, first off, I guess that question was what is a spat, right?
Oh, yeah.
Which you answered.
Yeah, which you answered perfectly. And it solved for oysters, which are sessile. They don't move, right? It solves the problem of how do we get oysters in places that are not literally next door? How do we spread these genetics to a more diverse space and sort of ensure the population as a whole? And they really love to land on other oysters, right? It's like the best possible place for their recruitment.
Well, in nature, that is the ideal, settlement habitat. I mean, that's what they're adapted to hone in on.
It makes a lot of sense because if there are oysters already in a place, it means that there's enough flow, there's enough food in the water column, there's not a ton of sedimentation happening. If there's already oysters there, it seems like a good place to set up shop as an oyster.
Precisely. You stay out of the mud and you get plenty of water flow, you're in good shape if you're an oyster, especially if you have good oxygen and food.
So, and I guess that brings me to another question, just as we're building this foundation of what are oysters, what do they need, is what are some of the environmental conditions that make for healthy oyster spaces? So we talked about, flow, oxygenation, lack of sediment. What is an ideal spot for an oyster reef?
Well, basically you highlighted a lot of very important key identifiers. I mean, it's a coalescence of those things. So you want high volume water flow. You want good oxygen saturation. You want ideal phytoplankton profiles because oysters predominantly consume phytoplankton, although they technically are omnivores. They do eat a little bit of, organic matter and bacteria here and there. I would say anything that keeps them out of the mud or provides some form of three-dimensional structure for them to settle on really enhances their potential of survival. Where they're at in an estuary is important because depending on what's going on seasonally, you can have periods of low oxygen. Like say, for instance, if you are on an intertidal reef and you're an oyster and you're knocked sideways and you're laying on the reef, well, at slack tide in the middle of summer, at low tide, even if you're under a little bit of water, you're going to be getting really hot. You're going to be exposed to the sun. You're going to bake, right? So It's really placement. It's also exposure to some extent to disease. I mean, is there a lot of disease pressure in a place? Like here in Georgia, we have protozoan parasites that affect oysters and only oysters, not people, safe to eat still. But disease pressure here, even though prevalence is high, the disease pressure itself isn't high because we have a healthy population. Just like people that have to deal with something like diabetes or cancer, they're more susceptible to secondary infections or causes of mortality or morbidity. Here in Georgia, we have a healthy estuary, therefore our oysters are a little bit more resistant to some of these pathogens now. And part of that's also due to some of the genetic diversity from this very large breeding population. So
yeah, that makes a lot of sense.
So we've done a few episodes on seaweed and seaweed farming. And I'm interested to hear, how exactly does oyster farming work? Do you kind of set up a space and you're like, okay, this is the space. Now I'm going to obviously you don't plant oysters, but I'm going to go plant oysters out here and they're going to grow and I'm going to farm them. Or do you find a pre-existing location and say, okay, this is my space? How does oyster farming work?
Well, that to some extent depends on what state you're in. And that also depends on the product that you're looking to produce.
Okay.
If you're in Georgia, for instance, I'll use this as an example. There's two ways you can get a shellfish lease. But say, for instance, you're here in Georgia and you want to farm, there are many gears to what makes it happen and how it works. First, you get yourself a lease based on the type of farming you want to do. Let's say I want to do floating farming, okay? So the state will issue these leases and people will compete for them, and you'll meet the certain criteria, you hit the lottery, you get the oyster farm. Now you have to determine what gear do you want to use. Here in Georgia, you can farm oysters in floating cages now. So that means you have to determine which cage you want.
So we've got these cages. You don't just set them out there and hope oysters recruit onto them, right? You have to seed them or get oyster stock for them.
So what we do here is we produce the oyster seed. The oyster seed is then distributed to growers, and those growers stock that oyster seed into their gear, and then they farm depending on which method they're using. So say, for instance, you use an oyster grow. It's a big cage, square. It's got floats on it. It's got levels. You put those oyster seed into a bag, stocked at a reasonable density, therefore they're not crowded, and you would flip that cage at least once a week to prevent soft biofouling if you're in a floating environment, because then you restrict flow if you do not do that.
Right, because basically what that means is that algae or other bacterial mats can form on that bag and restrict the amount of water and therefore the amount of resources coming into your oysters for them to grow.
Correct.
So we hear a lot about oysters in Apalachicola and over farming oysters and the polluted water, and so they can't farm the oysters. And so a lot of my knowledge is with the oysters in Apalachicola and being like, oh, well, there's like a shortage. Is that the case in other places? Like, do we have a shortage of oysters, or oysters just doing great? Is it okay to keep eating oysters? What's going on with oysters?
So if you're talking about shortage, do you mean a shortage of wild oysters? Or do you mean a shortage of oysters in the whole supply chain? Because I would say right now, if you can produce farmed oysters, you can sell them. I mean, there is definitely a high enough demand to sustain continued growth in this sector of aquaculture. Mm-hmm. If you're looking at wild fisheries, it's a little bit different because the demand's there, but the livestock has been decimated in some locations, or it's succumbed to degradation due to environmental causes or disease pressure. That's not something we have really here in Georgia now. Back in the turn of the century, 1900s, there was heavy exploitation of resources here in South Carolina that degraded a lot of reefs, but we have pretty healthy oyster stocks here now.
Okay.
I would say that, this also leads me, I wanted to get this point in earlier and I just kind of forgot about it, but that leads me to the whole, statement here that there are less wild oysters available in general because it's labor intensive to harvest them, and a lot of populations have been over harvested. Not necessarily because all wild populations are in decline, because like I would say here in Georgia, they're doing good. In Apalachicola, they have dealt with many stresses. Overharvest stress, limited disease pressure, but you've got the BP oil spill, you've got all these different things that potentially could affect oysters, for instance, in the Gulf versus here. So there has been limitation to access to wild oysters. But I would say with farmed oysters, there's room for growth, there's an excessive demand. I would still say that those oysters are readily absorbed by markets within our country quickly. Mm-hmm. So
yeah, that makes a lot of sense. And it brings me kind of this, taking it back out of the aquaculture space and into more of our wild oyster reefs. I think I was reading in prep for this episode something, don't quote me on these stats, but it's been something like an 85% reduction in oyster reefs worldwide over the last 120 years due to stuff like over-harvesting and decimation of habitat for development of beachfront condos and, turning these ecosystems that do a lot of ecosystem services into other habitats for human use. So what are some of the threats that are facing wild oyster populations, and what are some of the benefits to humans of having a healthy oyster reef out in the wild?
The benefits to having them in nature are diverse, and there are many. Everything from shoreline stabilization to habitat provision. They support economically communities of people that have existed along the coast for many years. All the way back to when they used to have, shell middens here, and people used to live and primarily using oysters as a protein source. They enhance the removal of nitrogen from our systems. To some extent, they sequester carbon. So they're critical habitat for several other commercial species during certain portions of their life cycle. Therefore, you definitely want to protect the natural oyster habitat, and you could benefit from restoring it in areas where it has been removed.
Yeah, and I mean, really what we're talking about here is this widely dispersed organism that creates structure. Structure supports biodiversity, and it also supports the maintenance of an ecosystem in the sense that literally having oyster reefs in your intertidal system prevents sediment from washing out to sea. It helps capture all of the stuff that's coming in from the terrestrial ecosystem into the waterways, trapping it there and keeping it in one place. And it also acts greatly as stabilization in these high energy marine events, right? So like they reduce some of these tidal actions that cause erosion and ultimately changing the landscape in a way that is probably not awesome if you like visiting the coast, right?
Yeah, absolutely. Definitely not to the same extent, but it reminds me to some extent of some of the benefits afforded to the shorelines, as you would see in some of the mangrove estuaries, where mangroves dissipate quite a bit of wave energy. At least that's what they're noticing at Rosenstiel School of Marine Sciences with the research that they do. Oysters don't do it to that degree, but they definitely prevent, habitat loss, shoreline loss, and they help to build shorelines back up, which is why they're an integral portion of the living shoreline design.
I'm so glad you said the living shoreline design, because it's a term that I've seen floating around, and I think I've got a general understanding of it. But can you describe for me what is a living shoreline and what are the benefits that it brings to a system?
So, okay. My understanding of living shorelines is fairly limited. I want to tell you that now.
He's like, I shouldn't have said it.
Yeah, well, so I will give you the 100-foot view or 1,000-foot view, however you want to say.
That's perfect.
Basically, using different tools to help provide a naturally restored shoreline. It seeds a natural habitat that continues to progress and become almost an indiscernible portion of the natural shoreline.
So it's, instead of using, giant pieces of rock or concrete to stabilize a waterway, you put it literally on where the water meets the land as a way to prevent the water from pulling that sediment out and downstream. You're instead supporting that ecosystem by adding in oysters, even just oyster shells upon which other oysters can recruit and grow. And these naturally occurring organisms that, by virtue of putting out roots or growing out, this physical structure of shells and stuff, it stabilizes that shoreline in a self-sustaining way, as opposed to requiring maintenance, adding new sediment every year or adding new rocks or concrete structures that eventually break down. It's just replicating what nature does.
You should have answered the question, man. I mean, you did it better than I did.
He knew the answer when he asked you. So a second ago, you mentioned the importance of restoring old oyster reefs, habitats that have been degraded, I guess is the word. Mm-hmm. Is the process of restoring those habitats the same as farming?
There's many types of manipulation of the natural environment. Back in the 1800s, they passed a law in Georgia, and a guy named Omler discussed the need to culture oysters, and his idea of culturing was breaking down the natural reef. Okay? That is not environmentally sound, but from a commercial standpoint, it makes a lot of sense because you get a good product out of it, which is what they use for the cannery industry in South Carolina and Georgia for, many decades. I
mean, so that's literally like, hey, here's an oyster reef that's existed forever. We're going to go put people out on it with, hammers and chisel off chunks of oysters or individual oysters and then take them to market.
Or dredge it or drag a railroad track across it, But the next step is something called semi-culture, which you've seen in parts of the Gulf, where they'll take oyster shell collective chunking houses, move it to areas where natural oysters settle. They'll take that naturally, shell product with the oysters spat on them and distribute them in good growing grounds. That is it's called semi-culture, or it used to be called semi-culture in the older literature. And that is an effective way to improve the fishery. You're still relying somewhat on natural wild resources, and then redistributing them, and then you have the actual culture of the animal where you're starting with, the animal as, an oyster seed that's been produced in the hatchery and then farmed in a cage. And to circle back to what you asked, please remind me what that was again.
Is oyster reef restoration the same as farming?
Yeah.
Like, is it the same setup?
No. So I would say it's more, in a way, it's kind of like semi-culture that you don't reharvest.
Okay.
In Georgia, we've looked at a couple different methods to conduct restoration. Some of it is bag shell. You put it out, you collect the natural spat, you get a good result. Some of it is taking bag shell and putting it into setting tanks here, putting larvae in there, having them settle on there, putting it out there when natural recruitment's not occurring, and we have gotten a statistically really good result. But something else we've tried is right out of the shell relay books of the Gulf of Mexico or some of the northeastern states that do some similar things, where we have taken shell, set it in tanks loose with baby oysters, and distributed it loose to create habitat. No plastic, nothing negative going into the environment.
Right, because of the bag situation, you're taking like just a plastic net, basically filling it with shells, and then setting that out in the environment.
Right. They have this plastic that, it degrades very slowly, and essentially the shell covered in the newly settled oysters will be in that bag. They'll grow through that bag. The stuff in the center dies. The veneer remains alive. You still have plastic encased in that oyster reef.
But theoretically, it's encapsulated.
It's encapsulated. I don't want to go down the microplastics road because it's a new area of research, really. Most recently, I've been hearing a lot about it with shellfish particularly. But I would say that anytime you can create a situation where you're using only natural products that belong in nature to restore an environment, you're creating a much better situation. And even, oyster shell, to use it in restoration, you're going to have to collect it from someplace, right? So in a way, it's like aquaculture that you're using the shell, whereas intensive oyster farming, you're actually taking seed and you are really manipulating the environment to get them to grow the way that you want them to grow. So I would say that that's the best way I could answer your question, is restoration and aquaculture the same, because there are aquaculture applications that are used in restoration, but with aquaculture, the way that we're doing it now intensively, you are removing the need for the use of the wild shell resource that really belongs in nature.
Yeah, and it's a lot of similar techniques with different end goals, right? In terms of like how we're growing things, but the restoration is not relying on that same type of resource like you were saying, right? Yeah. So excuse me, I'm about to get really sciencey here. Because
That's okay, we'll bring you back.
As I was prepping for this episode, I ran across the fact that a lot of times in aquaculture, you use triploid animals because they have they just respond differently than diploid animals. And so to sort of do some definitions here, right?
Sure.
A standard cell in an animal is diploid, meaning, each chromosome comes as a pair. Mm-hmm. Triploid animals have 3 sets of each chromosome, which as an individual is fine, but it generally makes them unable to reproduce, right? Because they can't typically go through gametogenesis where they're creating viable sperm or viable egg cells that could then make a fully formed organism. That's
a complicated answer to produce a triploid. And yes, you're correct. 2 sets of chromosomes for diploid, 3 pairs for triploids. There are chemically induced triploids, and then there are triploids that are produced through the pairing of a diploid female with a mated tetraploid to produce triploids. And though triploids typically don't produce viable gametes or spawn, sometimes triploid females will produce viable eggs, which is how they actually are able to produce tetraploid oysters for use to produce triploids.
Interesting.
So it's a long process. It's a difficult process to do, in any particular lab, but the people that have done it have got it down to a science. Cliche, but they really do. So,
and it's really cool because it's this technique. A lot of times when we're talking about cultured organisms, there's a big conversation around releasing non-native genetics into a native population. And you can mitigate that a couple of ways by, relying on native genetics to get your cultured organisms, or, it's either that or you come up with some way to stop the cultured genes from getting out into the native environment. And that's one of the ideas behind using triploid organisms. Like I know that they've released a triploid grass carp into some of the waterways to eat non-native plants.
Yeah, and to clarify, triploids aren't going to make any meaningful contribution to the population. Basically, to just go on the known science is that they undergo, to some extent, the process, some of them go through the process of gametogenesis and never produce viable eggs or sperm. Most of them, 99% probably don't. But there's a handful of females that will produce viable eggs that are then extracted to use to induce tetraploids chemically.
And if you were to do that in a natural environment, they would be outcompete.
You'll functionally never find a triploid oyster, in nature. I mean, easily anyway. I mean, they had the possibility exists that they could be there, but you're likely not going to go out and harvest oysters and take one to a lab and they're going to put some of the cells under the flow cytometer and determine, this is a triploid. That's probably highly unlikely. Yeah. And even the tetraploids, which can spawn, if they do spawn, the byproduct is essentially a functionally sterile animal. Yeah. Okay, so there's no real impact to the native population by farming triploids or tetraploids in any respect.
Yeah. But so then I guess the follow-up for that is, what is the value of triploid animals in a cultured setting? So like these animals that have extra chromosomes and are functionally sterile and unable to reproduce, why is it valuable to have them as seed?
So growth rate and meat condition. So triploids have a more uniform meat quality year-round because they do not spawn. So hypothetically, let's say you get a triploid that does some minor gametogenesis, but it's not going to spawn. Therefore, if you're shucking it in the middle of summer, you get a very nice meat yield. Whereas if a batch of diploid oysters spawn, they spawn intensely. You're going to have a watery animal. The quality of the product is low. Also, here in the South, a lot of people want to get ahead of that biofouling due to spat recruitment. So triploids that we produce here, I mean, they can become legally harvestable in easily 6 to 8 months based on just the legal limit you can actually sell them, which is 2 inches here in Georgia. Mm-hmm. They can get to 2 inches pretty quick here.
So really, I guess the idea is that because they're not putting energy into reproducing, they're able to instead spend that energy on growing an oyster, right? So in much the same way that I like houseplants, and so I've got some succulents, like cactus-like things, and I've also had Venus flytraps. And all of the forums say that if it starts to produce a flower stalk, you should cut it because it takes so much energy for that organism to grow that flower stalk and prepare to reproduce that it actually is detrimental to the body condition of the plant itself because it's quote unquote wasting energy reproducing when it could be growing, right? So triploid oysters that are not going to reproduce and not putting energy into that, they just grow and mature faster and create a better product for market, right?
Yeah, well, they grow faster. They never actually fully mature. But yeah, I would have to say they put a majority of their energy into somatic growth or cell growth versus diploid animals, which divert a lot of their energy to reproduction during certain times of the year. You'll have this pulse of growth in diploid oysters and then it will just stop. Triploids will continue to put on new shell growth. At least this is what we've observed in our broodstock reservoir. Because we put triploids sometimes aside for other research. So, anytime you're maintaining them, you can see that these animals are growing still. Whereas these animals have completely stopped, and that part of that has to do with the reproductive cycle, at least here anyway.
Yeah.
In the subtropics, growth is also faster because the water temperatures are higher, and we're in a very productive system, so there's plenty of food available most of the year.
Yeah, that's awesome.
Just kind of as we're wrapping up here, do you have any recommendations on things that people can do to help in the restoration of oyster beds, oyster reefs? You kind of briefly mentioned it, but I've seen some calls from some places that are like, hey, after you have an oyster roast or something, give us your shells so we can use them.
So we house the Georgia program here. It's a Generating Enhanced Oyster Reefs in Georgia's inshore areas. I think it's what the acronym means.
That was pretty good.
But we collect shell here, and that's one thing you could definitely do is donate as much shell as you can. We have these curing piles, and we put the oyster shell there, let it cure for a minimum of really, I think you only need 3 months, but we do it for at least 6. And then we'll use that shell to bag it up or just set it and then put it out as loose shell with spat on shell for restoring reefs. Another thing you can do is, talk to your local representatives and let them know, hey, we should be supportive of, the UGA Marine Extension, Georgia Sea Grant, and the DNR and the programs that they have to work to restore some of these habitats. So please, if you can, toss a little money.
Yeah.
They're a way to help expand these programs to restore some of these historic areas that have been over-harvested, that haven't really recovered. That is another way people can help. But most directly for us, it's the collection of the shell. And we use that shell to then build reefs and participate in other projects sometimes with other states. So
it makes me want to go. So we live in Columbus, Georgia, which is, we're up the Chattahoochee. There's not always oysters in the area, but we have a couple of restaurants in the area that I know regularly serve oysters. It makes me want to go to those restaurants and be like, A, what are you doing with your shells? Are you participating? And B, are you supporting Georgia oyster growers? Or, do you ever bring in stock from locally?
Georgia.
Because I would love to support this industry through our local restaurants. I think that would be really cool. I actually don't know that I've ever seen Georgia oysters on a menu. Not that I eat oysters all the time.
Well, I know the last time we had oysters, I think they were from Virginia.
a lot of them come from the James River in Virginia.
Yeah.
If you want local oysters from Georgia here, you have to be at a restaurant that purchases from the growers during the open season. Usually they close the season around when the water hits 81 degrees and they open it when it gets back under 81 degrees. But most of those are going to be on the coast. If you want to eat them locally here, I mean, you can do it a couple places like the Husk or Common Thread or Seawolf out on Tybee Island. The Gray is another big one. If you're in Atlanta, it's the Kimball House. They serve Georgia oysters usually in rotation. Right now, we have two major oyster farmers. There's more coming online right now that have just been awarded leases, but two of our most prominent intensive oyster farmers are the Tybee Island Oyster Company and Ernest McIntosh and Sons. Sorry, there's only one son. sorry, Ernest Jr. So, I mean, they sell their stuff. The McIntoshes sell their stuff to like Whole Foods, I believe, in Atlanta, and they sell it coastally. And, you know, there's also Sea Bear in Athens. They do Georgia oysters, they do McIntoshes, and I'm probably going to do Tybee Oyster Company too. So
that's awesome.
Yeah.
Cool. I know that we're almost done here. I can see you being like, all right, let's wrap it up. But I
have an important question, but I'll ask it later.
You do?
Yeah.
Oh, well, I wanted to talk. I mean, so I only kind of got into oysters in the last 5 or maybe 10 years of like really enjoying eating them on the half shell. And, you know, you notice such differences when they're from different locations. Mm-hmm. You know, oysters from Washington look and taste different from, you know, James River, Virginia. What do Georgia oysters taste like? Like, how are they characterized as an oyster on the market? Do you know? Is that something you feel confident speaking about?
Well, I can give you my experience.
There you go.
Okay, I can't really tell you what everybody else thinks, but you know, back when I was farming, my wife and I, we used to eat a lot of them from my lease, and I used to like the oysters grown right there off the Medway Spit, you know, near Sunbury, and they reminded me a lot. You'd get a lot of the marsh smell. You would smell a lot of the warm Georgia marsh in the summer, and not the stinky, sulfury smell, but the nice. Yeah. Ocean salty smell, and the flavor of lemongrass really came through to both of us. My wife is a white wine connoisseur, not really, but I mean she really likes Sauvignon Blanc, and she used to love to pair, you know, salty Georgia oysters, which they are salty here. Our salinities are pretty high in our sounds. So to me, a Georgia oyster, in my mind, smells like the Georgia salt marsh on a fresh day with heavy influences of salt and lemongrass, and is best paired with a New Zealand Sauvignon Blanc because they tend to have more of those grassy undertones.
That was a beautiful description.
I should have expected it as somebody who has commercially grown oysters himself, but like that was an incredible description of our oysters here. That's fantastic.
Thanks. I actually went back in time in my head, but I have had, you know, the local oysters here, Tybee Island Oyster Company and McIntosh and Son. Their oysters are quite distinct from each other, and they are both remarkable. And most of the time, or the only times I have actually had them, they have been very salty. And there's a lot of similarities to the oysters that I used to get from my old lease.
That's awesome. Sarah Catherine, do you want to get some oysters after this?
Yeah, I would love to go find some oysters. Okay, so my question was, and it was kind of answered through Chance's question. I was going to ask, do you like oysters? Which I assumed you did, and it seems like you do, or at least you have. My follow-up question now, since that one was kind of stolen, is...
You're welcome.
What is your favorite way to eat oysters? Because there's a lot of ways to prepare them.
So I will tell you, I used to eat oysters prolifically. But after working with them for so many years, you become fairly intimate with them.
Yeah, that's fair.
And I do like to eat oysters on rare occasion. For me, it is more of a connection than it actually is a, gastronomic or, food-related drive. So the way that I like to eat my oysters is just ice cold, and I like to eat them with nothing else on them, and I like to eat them in the winter, usually in January or February. So that's when their condition is really high. Usually salinities are technically pretty high here because we get more rain in the warmer months surrounding spring and late fall when the season is actually open.
Yeah. Cool.
Good to know. Well, if you're listening, support your local Georgia oyster growers. And
or wherever you're located, since we have listeners everywhere.
Support them all.
Support everyone.
And really, I mean, that's a good point. Support sustainable aquaculture because it is a massively important protein resource for a growing population, and it provides economic ability to coastal people, which are very, coastal communities are at risk for great issues with climate change and changing oceans, and B, historically economically depressed. So support your local aquaculture.
Support working waterfronts, and if you don't mind me stating,
please,
if you want to access resources on how to support your local oyster farmers or local working waterfronts or shellfish, providers and farmers, please go to the Georgia Sea Grant website. Please go to the Oyster South website. Please go to the East Coast Shellfish Growers Association website. Oyster South and UGA Sea Grant are particularly good resources for you. Oyster South has been a growing movement over the last, I want to say 5 to 10 years, and maybe it's less than 10 years, but it's amazing what they're doing with farmers from all over this country, not just in the South. So
that's fantastic. So you guys can scroll down to the show notes. I'll put some links there. Thank you so much for being on the show with us today.
Pleasure. Thanks for having me.
I have to say, I think that the way that he described the flavor of the oysters from his lease when he was farming is maybe one of the most beautiful descriptions we've ever had on the show. I mean, he gave us wine pairings. He gave us all of these wonderful tasting notes. I was very impressed.
Yeah, I know. It makes me want to go to a really nice oyster house and have some oysters and some wine.
I mean, that sounds like a great date night to me.
Another thing I really liked about this episode was how he explained kind of the difference between oyster farming, aquaculture, as well as harvesting. I even asked a question of something around oyster farming that I didn't phrase it the right way because I was actually thinking of harvesting and not farming.
Right. Sourcing wild oysters from naturally occurring reefs versus sourcing oysters from people who are growing them commercially as aquaculture. There's a difference there.
Yeah, absolutely. And I think this episode ties in well. See, you guys maybe have figured it out by now. We kind of have a plan for some of these seasons, and we're like, oh yeah, this ties in well to this episode. But I do think that this episode kind of ties in really nicely to the next episode that we have coming up that we actually just recorded in Dallas at EarthX.
Yeah, so last week we got to talk to Adam Hussein, who is the director of a film that's still in production, a documentary called Seaforestation. Not deforestation, seaforestation, because he was talking all about kelp and the struggles that it's facing kind of worldwide as ocean temperatures change, as well as how many incredible things kelp do in an ecosystem, both for the environment and for people.
Yeah, absolutely. And we've had a few discussions on seaweed farming in the past, and we've talked about the benefits that coral reefs provide. And even in this episode, we talked some about how oyster reefs can kind of mitigate some of that habitat loss, habitat destruction, kind of cause a bit of a wave break and things like that.
I honestly would not be surprised if once we're super famous podcasters and have made all of the money we're going to make, if we just retire to a seaweed/oyster farming outfit somewhere on the coast and just live out our days doing aquaculture.
Yeah, we've talked about it a few times. I'm sure it is more difficult than we've worked it up in our heads to be. It sounds like this life of luxury living by the sea, but I have no doubts that it is more difficult than that.
Yeah, I fully believe that it's hard work, but also like how satisfying must it be to be a seaweed farmer? I think that'd be super cool. Anyway, next week we're going to showcase a really cool conversation with Adam about the roles of kelp and kind of how he got into filmmaking and the story that he wanted to tell.
Yeah, it should be a really cool conversation. I'm really excited for our audience to hear it and to get a bit of like a taste of what this EarthX season, our next season, will look like.
Next season is going to be really, really cool. A few last little housekeeping notes. I just want to say thank you to you guys for leaving reviews. It helps other people find the show, and that's the whole point of our nonprofit, is to educate as many people as we can. So if you haven't rated us yet, and you could take a minute to go leave us a 5-star review on Apple Podcast or Spotify or wherever you listen, it really does make a difference for us.
It definitely does.
See you next week.